Okay, so in this video we're going to look at a proof by induction exam question involving Moivre's theorem, and it's worth 15 marks. So we have our question as usual: prove using induction if n is a positive integer, so that's just always associated with Moivre's, that's all. And then they've given us what to prove here. They remind us that I squared is equal to -1. So as always, step 1, we're going to prove true for n equals 1. So we get cos theta plus I sine theta to the power of 1 will equal to cos of 1 by theta plus I sine 1 times theta. So this is like, we treat this as left hand side and then right hand side. So left hand side becomes cos theta plus I sine theta will equal right hand side, we get cos theta plus I sine theta. So it's true for n equals 1. Step 2 then, we're going to assume true for n equals k. So we get cos theta plus I sine theta to the power of k equals cos of k theta plus I sine k theta. Okay, we'll come back to step 2 in a second. Step 3, we're going to prove true for n equals k plus 1. Okay, so we have cos of theta plus I sine theta to the power of k plus 1 will equal cos of k plus 1 theta plus I sine, and same again, k plus 1 theta. Left hand side we rewrite and we get cos theta plus I sine theta to the power of k times cos theta plus I sine theta to the power of 1, and that's going to equal cos of k theta plus I sine k theta plus theta. So right hand side for this from now on would stay the same, and our goal is to manipulate the left hand side so it ends up looking like the right hand side. Okay, so I'll come back now to my step 2, n equals k, and that tells me that cos, which I have here, cos theta plus I sine theta to the power of k, I can replace it with this. So that'll give me cos k theta plus I sine k theta multiplied by cos of theta plus I sine theta will equal the right hand side okay, and now brackets mean multiply, so I'll have cos k theta by cos theta plus I sine k theta cos theta plus cos k theta I sine theta, and then plus I sine k theta I sine theta equals the right hand side. Okay, so we have two parts in our log tables that we're going to use now. Bring them across here. And that tells me cos of a plus b. So what happens here is a will equal k theta and b will equal theta. So if we look here, then we're going to have cos a, cos b, and then we have a sine a, sine b, cos A, cos B, and then we have a sine A, sine B. Now, one thing to be careful about, we have I and I, which will give I squared. So we'll do a little bit of rewriting there. That'll become -1. And then we'll have our, in the middle here, the imaginary parts, because they'll have I attached to them. And then left over here, we'll have the real parts. So we're just going to rearrange so they're beside each other. And we're also kind of thinking about our two identities here. So we get cos k theta, cos theta, and then plus I squared sine k theta, sine theta, plus I sine k theta, cos theta, plus cos k theta, I sine theta. That equals your right hand side. Okay, so I squared we swap out for -1. That equals the right hand side. And we'll just impose the formula on top for a second. So that told us we have cos A, cos B, minus sine A, sine B. So that matches that one. And then we have plus I sine A, cos B, plus cos A, I sine B. So now we can swap out, and that means for our left hand side tidies up to cos of A plus B, which is k theta plus theta, and then plus this whole side here will tidy up to sine A plus B, but we know in front of sine we have an I, so that becomes I sine k theta plus theta. So there's my left hand side tidied up. And now we write our right hand side. And we find that they equal each other. Okay, so it's true for n equals k plus 1. And now our statement at the end. So we had cos theta plus I sine theta to the power of n was left hand side equals cos n theta. It's going to equal cos n theta plus I sine n theta. And then for all n element of n, usually would be our statement, but in this case we don't need it. And then our copy and paste bit, as we have proved true for n equals 1 and n equals k plus 1, assuming true for n equals k. Okay, so there's that question answered. Again, a little bit longer than your inequality, divisibility, or series proof, but just our goal, as always, is to make the left-hand side equal to the right-hand side. And that's us done.